So hello everyone, my name is Ujjwal Prasaini. So I'm gonna be presenting the topic BitVM, which is in short for Bitcoin Virtual Machine. So it is a breakthrough technology enabling complex smart contracts on Bitcoin without changing consensus rules, expanding Bitcoin's functionality far beyond its original use case while preserving its security model. So we have our table of contents here, so which includes the introduction to BitVM. So it has the Bitcoin scripting limitations, the technical implementation of BitVM, application and use cases, future works, and conclusions. These are the topics that we'll be discussing in the later slides. So let's start with what is a BitVM. A BitVM is a novel approach that enables any computation to be verified on Bitcoin's blockchain without changing consensus rules. It also preserves the Bitcoin's security model while expanding functionality. It also moves heavy computation off-chain using the blockchain only to check and enforce results. So Bitcoin's base layer was intentionally limited in scripting capability to prioritize security and simplicity. This means Bitcoin cannot natively run complex smart contracts like Ethereum can. So that's why we propose BitVM. BitVM it enables any computation to be verified on Bitcoin's blockchain without changing consensus rules, effectively making Bitcoin Turing complete for contract verifications. In simple terms, BitVM lets Bitcoin handle advanced smart contracts by moving the heavy computation off-chain and only using the blockchain to check and enforce the results. So this breakthrough has generated excitement because it expands Bitcoin's functionality far beyond the original peer-to-peer cash use case while preserving its security model. So we're gonna be talking about how BitVM works, like the core concept. So BitVM is a computing paradigm that uses Bitcoin's existing script and taproot features to create complex contracts. Rather than running contract code on chain, BitVM runs computation off chain and uses Bitcoin as a code to verify outcomes. The core idea is similar to optimistic rollups. One party, a prover, claims a certain computation result, and another party, a verifier, can dispute false claims via a fraud-proof mechanism. If a claim is proven false, the dishonest party loses a security deposit on chain, ensuring strong incentive for honesty. So it has a two-party protocol. So in BitVM, in initial design, every contract is between two roles: a prover who executes a program off-chain and a verifier who checks it. They first agree on a program and compile it into a Boolean circuit, logic gates operating on bits. So the prover then commits to this program and its expected outcome on chain, typically by creating a taproot output that contains a Merkle tree, which is essentially a tab tree of all the logic gates and steps in the program. Both parties lock funds into this contract as collateral. They also pre-design a sequence of Bitcoin transactions representing a challenge response game. Once set up, the prover executes the program off-chain and shares states updates with the verifier, and no blockchain activity is needed if both agree on the execution in the two-way party protocol. So we have the technical. foundation here, uh, which has the hash lock, time, time lock, and taproot. BitVM leverages standard Bitcoin script primitives like hash lock, time locks, and especially Taproot's flexible scripting. Taproot, which was activated in 2021, allows hiding many possible script in the output. So this is the dispute resolution mechanism of BitVM. So we have the dispute initiated where verifier detects incorrect claim and challenges the prover on chain. And then we pinpoint error. The strategic challenges identify the exact step where the prover's claim went wrong. Then the verifier presents evidence of the incorrect computation, and then the penalty is enforced where the dishonest party loses security deposit on the chain. So, so this design ensures minimal on-chain footprint. In the optimistic case, no dispute. Typically, only two or three transaction towards the blockchain. Example, funding the contract and the final statement. In a pessimistic case, that is dispute, additional transactions are used, but BitVM's designs keep the number logarithmic in the size of computation or even constant round in newer versions. All heavy processing and storage happen often between the participants, preserving Bitcoin's performance and decentralization. So we have a chess game example here to illustrate. Like imagine a BitVM contract for a simple game of chess between Alice, who is the prover, and Bob, who is the verifier. The entire chess game rules are committed in a taproot output. Alice and Bob make initial deposits and then play the game off-chain, exchanging moves. If Alice tries an illegal move or claims victory illegitimately, Bob can halt and initiate a challenge. The BitVM contract might have a script for each possible move in the Merkle tree. Bob would reveal the move in questions and use the pre-signed challenge transaction to invoke the corresponding script that checks the move's validity. If Alice's claim was wrong, the script's condition fall and Bob wins Alice's deposit, which is basically penalizing the cheat. If no one cheats, the game completes and funds are settled according to the outcome with just one final transaction. This way, the full complexity of chess, a very complex game state, is kept off chain and only a tiny proof goes on chain if there is a dispute. So we have the comparison of BitVM to Ethereum. So unlike Ethereum's EVM, which executes a smart contract code on chain in a global state, BitVM does not execute arbitrary code on every node. Instead, it verifies computation on a need-to basis. This means BitVM contracts are not global. They are specific agreements like state channels, typically between two parties. Ethereum allows multiple users to interact with the same contract freely. BitVM, in its initial form, is limited to a two-party contract at a time. This limits BitVM from directly replicating complex DeFi protocols with many participants or open-ended apps. However, the BitVM's approach avoids the gas fees and performance cost of executing every step of every contract on chain. In effect, BitVM moves Bitcoin towards layer 2 smart contracts, analogous to how rollups work on Ethereum, but tailored to Bitcoin's conservative design. A BitVM contract can be seen as a custom layer 2 for the specific application anchored by Bitcoin's security only when needed. So we have the comparison of BitVM to sidechain. So prior to BitVM, adding smart contracts to Bitcoin often meant using sidechains or separate network. For example, Rootstock is a sidechain that brings an Ethereum-like EVM environment to BTC, but it relies on a federation or merge mining for security data. Stack is another blockchain that settles to Bitcoin but has its own consensus and language. This solution requires trust in separate validator or new infrastructure. So BitVM, by contrast keeps trust minimized on Bitcoin itself. All dispute resolution ultimately comes down to Bitcoin transaction and cryptography, not a third party. This could enable trust minimized breaches and rollups, where BTC moves to a second layer without relying on a federation to guard funds. BitVM essentially offers a way to implement a sidechain or layer 2 inside Bitcoin's existing rules, using contracts and fraud proofs instead of alongside it. So, so we have the BitVM's relation to Lightning Network. So Lightning Network is a well-established Bitcoin layer 2 for fast payments using hash time lock contracts, yes, DLC, and channels. BitVM shares some conceptual similarity with Lightning. Both use off-chain transaction and pre-signed on-chain transaction for enforcement. In fact, BitVM can be seen as a generalization. Lightning is specifically about payments between parties, whereas BitVM could handle arbitrary state update and logic between parties. They could even complement each other. For instance, BitVM's idea could be used to create a channel factories or manage multiple Lightning channels in one contract, something researchers have noted as a future possibility. Another connection is that the BitVM's two-party design can potentially be extended in a hub and spoke fashion. One party opens up a contract with many others, akin to how Lightning hubs connect multiple channels. So these are the key use cases. Uh, so we have the trusted minimized breaches first. So perhaps the most immediate use case is creating like safer bridges between Bitcoin and other chains or side chains. Currently, moving BTC to another network like Ethereum and L2 involves trusting a federation or a majority of multi-sig custodians. With BTPM, a bridge contract could lock BTC on Bitcoin and mint a wrapped version on the other chain. With the BitPM contract enforcing that withdrawals from Bitcoin side only happens if the corresponding bond on the other chain is proven. By using fraud proofs such as BitPM Bridge can ensure that no custodian can steal funds. At worst, if all operation turn malicious, funds would be frozen or burned but not stolen. This drastically improves security assumptions from trusting many keys to needing at least one honest participant. A demo of BitVM powered BTC Bridge has already been showcased on Bitcoin as Signet test network, indicating real progress towards this application, which is with deposit withdrawals and challenge transaction executed on a test chain. So another use case is decentralized finance on Bitcoin. So by enabling like complex contract logic, BitVM could allow Bitcoin to host uh, DeFi-like applications such as lending, decentralized exchange, or derivative instead of moving BTC to Ethereum to participate in DeFi. User might engage in Bitcoin native contracts. For example, two parties could create a BitVM contracts that functions as a synthetic assets or option contract using Oracle and time-locked outcomes. While BitVM initial design doesn't directly incorporate Oracle, developers could feed signed data into the off-chain computation, as noted by observers. Making Bitcoin more programmable could attract new users and capital, countering the notion that Bitcoin is a boring blockchain. Uh, Greater expressiveness could help Bitcoin tap into the booming DeFi sector without sacrificing its base layer stability. However, the lack of native oracles and multi-party coordination means early BitVM DeFi might be limited to simpler two-party construct or rely on external oracle services. So we have another use cases which is gaming and fair protocols. The BitVM paper explicitly mentions games like chess, Go, or poker as potential application. Two players could play a fully trustless game of chess with money at stake. For example, the entire game logic would be enforced by the BitVM contract so that neither player can cheat. Any illegal moves can be challenged and punished. So this extends to any two-party algorithmic interaction, lotteries, puzzles, or even things like prediction markets, two-party ones. So could be implemented. One could also create fair exchange protocols or contractual agreements like escrow with elaborate condition using BitVM's flexibility. So another use case is optimistic rollups. So in a longer term, like BitVM could serve as a foundation for Bitcoin rollups, a scalable chains that post data or proofs to Bitcoin. So BitVM itself is not a full rollup, but its verification scheme could anchor one. For instance, an optimistic rollup running many transactions off chain could periodically commit state roots to Bitcoin. BitVM contracts would allow anyone to challenge a bad state transition by breaking down the rollup state computation into bits and verifying it. Essentially, BitVM could enable a Bitcoin layer 2 with similar guarantees to Ethereum's optimistic Arbitrum. This means high throughput and lower fees, with Bitcoin as the final arbiter of security. Early experiments like BitVM2 rollups are aiming to demonstrate this, where an auxiliary network can handle fast transaction and BitVM ensures they're ultimately valid. Projects like Build on Bitcoin are reportedly combining Bitcoin and Ethereum tech to create hybrid layer 2s using BitVM concepts to secure Bitcoin's role in DeFi. So we have another use case which is zero knowledge proofs, validating zero knowledge proofs. So a very technical but powerful use case is verifying large zero knowledge proofs on Bitcoin. Normally, running a snark verifier in Bitcoin script is impossible due to size limits. BitVM can break the verifier algorithm into many small steps and enforce its steps correctness. The BitVM's design explicitly targets this scenario. Examples: implementing a Groth16 snark verifier as a series of sub-program in Bitcoin. And this could lead to JK rollups in Bitcoin, where proofs of entire batches or of transaction are verified via BitVM, or allow Bitcoin contracts to validate proof from the other chains, enabling trustless interoperability. In fact, BitVM's ability to optimistic validation of arbitrary computation, it's seen as a way to bring advanced cryptographic protocols like JK snarks or even new opcodes to Bitcoin without a fork. So we have the BitVM alliance here. So BitVM was originally invented and proposed by Robin Linus, a Bitcoin researcher and core contributor to the Jerosync project. Robin published the first BitVM paper around October 2023, outlining the concept and initial protocol. He later collaborated with academics and other developers to refine the idea. This led to a second iteration dubbed BitVM 2 in mid 2024 with major improvements. So notable co-authors of BitVM research includes Lucas Omori, Jetta Avrikoti, Mathieu Maffei, and others from institutes like University of Edinburgh and TU Wien. BitVM2 results were written up in a formal paper in late 2024, uh, revised April 2025, which provided a rigorous security analysis and even a prototype implementation of evaluation. This academic collaboration demonstrated that BitVM can be practical in the best case only. 3 on-chain transactions are needed, and even in worst case disputes, the number of on-chain steps grows only logarithmically with complexity. And they also showcased a Bitcoin sidechain bridge example using BitVMs, proving the concept of the code. So to coordinate efforts in turning BitVM from concept to reality into reality, the BitVM Alliance was formed, co-founded by Robin Linus and developer Lucas George. This alliance brings together several Bitcoin-focused teams. Members include like companies and projects like BitLayer, uh, Bob, which is built on Bitcoin, Citria, Element, Fiamma, Strata, and Jerasync, all contributing expertise and resources to advance BitPM development. This collaborative model allows for knowledge sharing and peer review, which is crucial given the complexity of BitPM smart contracts. BitLayer, for instance, has been working on documentation and tooling with Jerosync provide cryptography expertise. The project is developed as open source under the umbrella of the Jerosync nonprofit, and it has received funding from organizations such as Spiral, Blocks Bitcoin, R&D Arm, S- Starkware, leader in journalistic, and OpenStats, among others. This broad support underscores the community's interest. Both Bitcoin-centric groups and cross-chain JK groups are invested in BitVM's success. So we have the key contributors here. So the key contributors beside Robin Linus includes Lucas George and an engineer known as Still Psycho, who helps lead development. There have also been valuable contribution from the Bitcoin developers like SuperTestNet, who popularized the idea that Bitcoin could be Turing complete and help test it. Collaboration extend to academia, TU Vienna and Stanford groups mentioned earlier, and other innovators, for examples, Bitcoin core development developer Jeremy Rubin's ideas on check from stack are referenced in the BitVM design, and former developer Jeremy Rubin's idea are like are uh, referenced in the BitVM design, and former Bitcoin developer Salvatore Ingala's Merkelize all the things proposed inspired parts of the architecture. So, so this is the timeline of the concept to implementation. We had so in October 23, Robert Linus published the first BitPM paper outlining the concept and initial protocol, and then in mid 2024, BitPM to introduce with major improvements to the original data. Then in late 2024, formal academic paper published with rigorous security analysis and prototype implementation. And in 2025, official BitPM implementation in Rust available on GitHub with developer preview demonstrated on Signet. So these are the BitVM2 improvements. It has the permissionless verification. Anyone can step in as a challenger, not just the original verifier. This prevents collision between the prover and verifier. So we have the reduced on-chain transactions. So dispute resolution requires at most 2 transactions, significantly like reducing the on-chain footprint during the challenges. And it also has a simplified design, more elegant protocol structure, makes implementation and security analysis more straightforward. So while BitPM opens like exciting possibilities, it also faces significant challenges before it can achieve a mainstream adoption. The creator and community are well aware that BitVM is far from a polished solution. At this stage, here we outline the main limitation and how ongoing research might address them. So first, we're gonna talk about the two-party limitation. The original BitVM design only works for a single prover and single verifier. This means like it cannot natively support multi-party protocols or contract that many people can join, unlike Ethereum contract that opens to all. Like for example, you couldn't directly deploy an order book DEX or multiplayer game with one BitVM contract. You need to break it into many two-party agreements. This is a fundamental constraint that could limit BitVM's usefulness for decentralized applications. The BitVM 2 iteration has begun to relax this. It introduces permissionless verification, allowing anyone to step in as challengers even if they weren't a part of the original contract setup. In practice, like BitBM2 still may start with a setup operator or an initial group for things like rollup or breeze, but it ensures that any outside observer can police the execution. This improvement means a malicious prover cannot simply bribe or collude with a fixed verifier to cheat because any third party could catch them and trigger a fraud proof. Looking forward, research is exploring ways to support yan of yan or one to yan party models more directly. So we have another challenge, which is the off-chain computation burden. So BitPM achieves minimal on-chain uses by pushing computation data storage off-chain, but this implies a burden on the participating parties. They must handle potentially huge amounts of data and computation. If someone encodes a very complex program, the prover might need to perform millions of steps off-chain and store large transcripts of those steps, and the verifier must be able to process the challenges. As one source noted, off-chain computation will likely involve huge amount of data. This could limit who can run a prover or verifier. It might require significant memory, time, and perhaps a specialized software to manage the off-chain side. If BitPM were used for something like a roll-up handling thousands of transactions, the operator provers need robust infrastructures. However, because this all happened off-chain, it doesn't burden the global network. It's a scalability trade-off where clients do more work so the blockchain doesn't have to. The future outlook here is optimistic. Many layer 2 designs assume some nodes will be executors with more power, uh, and ordinary users just to verify occasionally or use light clients. BitVM could fit into a paradigm by having dedicated operators and community verifiers. Additional techniques like succinct proofs or improved cryptography might reduce off-chain load in the future. Example, like one could combine BitVM with GK snarks to compress the fraud proofs further. So we have another change which on-chain on-chain congestion in worst case. So we have if we if dispute occurs like frequently, multiple challenge transaction could consume block space. Early designs envisioned week-long disputes period for very large programs. So the mitigation for this is the BitPM2 improvements reduce worst case to logarithmic number of transaction. So optimistic case requires only three on-chain transaction, and another one is like careful parameter tuning can balance the safety and speed. So we have the another challenge which is complexity and security. So BitVM mechanism like involves many pre-signed transaction and clever scripting is like inherently more complex than regular Bitcoin transaction. With complexity comes risks of box, like a small script or error or missigned transaction could lock funds unintentionally or create an attack surface. So auditing and formally verifying BitVM contracts and the general framework is crucial like before real money is put into play. The project's code is heading for adults, and the academic work provides a formal model which helps. Another aspect is usability. Writing a program in terms of BitVM, Boolean circuit, and transaction is not straightforward for developers. There is mention of high-level languages like a C++ language or tools to compile code to BitVM format in the roadmap. So making it easier for developers to create and debug BitVM contracts will be important for adoption. The community might develop libraries or templates for common use cases, example like standard BitVM templates for a two-party game or swap. Over time, if BitVM proves valuable, we might even see proposals to add convenience to Bitcoin script or support it through the goal to avoid needing any protocol changes. So this is the BitVM's like unique value propositions. So there is no consistent changes. It works with Bitcoin as it exists today. So it also inherits Bitcoin's strong security model. Uh, it also enables Bitcoin to be Turing complete, as it enables arbitrary computation verification, and it also leaves minimal on-chain footprint. It preserves the Bitcoin's performance and decentralization. So this is the potential impact on Bitcoin ecosystem. So the Bitcoin future outlook of the Bitcoin, it's promising, right? It's seen as a potential important breakthrough for Bitcoin's long-term growth. If the technical hurdles are overcome, Bitcoin could usher in an era where Bitcoin is not only a store of value or settlement network, but also the backbone of a rich ecosystem of applications. User could gain access to the decentralized service with Bitcoin security. For example, imagine trustless Bitcoin-backed loans or playing betting games with BTC in a trustless way, or moving your BTC into an Ethereum layer 2 with no custodian risks. So many of these possibilities are in early stages and some may not materialize if the limitation prove too hard to solve. So it is also possible for alternative solution like drive chains or protocol upgrades could complete with or complement BitVM. So we have the community reception here in this slide. So we have a positive reactions. It's like it is held as a breakthrough for Bitcoin development. It shows Bitcoin's script limitation can be worked around. So it has sparked a new wave of innovation interest and its potential to expand Bitcoin's use cases. So the cautious perspective, I say, is like it's still it is still an experimental technology. So it's in its early stages and not production ready. So the complex implementation challenges still remains, and the security consideration needs thorough review. So these are the future research direction for the BitVM one. So we have the multi-party extension, which is like expanding beyond two-party contracts to support more complex applications. So we can also apply the compression techniques, which like reducing off-chain data requirements to optimize the protocols. We can also combine BitVM with Lightning Network for enhanced functionality. We can also use hybrid approaches using both fraud proofs and GK proofs. So, in conclusion, like BitVM demonstrates that Bitcoin can support complex application without compromising its core principles. It is an innovation catalyst, like it opens new avenues for developers to build on Bitcoin, potentially revitalizing its ecosystem. Uh, while promising, BitPM is still evolving. Its full impact will depend on overcoming the technical challenges that we mentioned before. So, for the future potential, we could make Bitcoin a platform for innovation again while preserving what makes Bitcoin unique. So, this is the end of my presentation. Thank you.